Traditional electrical power systems relied on strong generators, in which we had synchronous generators, transmission network, and consumers. So the transfer of energy was from generators over transmission line to loads. Today, the situation is different. Firstly, instead of synchronous generators, synchronously operating generators, we have, for example, wind farms, we have PV, solar energy, we have also storage units. And their nature is intermittent. We cannot always rely on wind farms because we can only forecast when wind farms will be available. Similarly, the same holds for solar energy. And the overall complexity of the system has been increased. The level of uncertainties has been increased. And dynamic properties of modern systems has been changed in the context of reduced power system inertia, in the context of reduced power system fault level. Power system inertia is related to the level of kinetic energy available in the system, which is very important for frequency regulation, frequency stability, whereas on the other hand, fault level has to do with voltage stability. These two stability aspects are the most critical in electrical power systems, and if any of these is becoming problematic, the system could go into cascading failures and the blackout, what has to be definitely avoided. 1 hour, in my personal opinion, is very complicated, but at the same time, prediction few seconds ahead is not helping us because system is already in a blackout. So we need to be capable of carefully designing such a system which could protect electrical power system and prevent blackouts. In this context, I see potential in applying artificial intelligence-based approaches which could run in parallel to existing approaches which are called system integrity protection schemes or remedial action schemes or special protection schemes. I wouldn't say that AI is cleverer than we are. AI applications are more able in the context that they can process more data in real time because our mental capabilities are limited from speed perspective, from quantity of processed data as well. However, AI can be clever as we are. And I don't expect AI to be cleverer as we are than we are. So that actually I'm talking about creativity. We can raise the question, can artificial intelligence-based approaches be creative? Creativity means to be innovative, to create something new. This is something what time will show. I would point out opportunities for monitoring, for so-called situational awareness. And electrical power system is affected by a number of changes. I have already mentioned changes in power system inertia or fault level. And there is a need for real-time monitoring of, for example, power system inertia or fault level. And this can be also done by using AI-based approaches. With my researchers in the past, I worked on power system inertia monitoring using neural networks, and we got very good results. We got results which could be definitely applied. However, I would like to point out that this is monitoring. We just monitor. It's not another level of complexity what is control. When we have to close the loop and make decisions and, for example, change the operation of a generator or change the network topology or even disconnect load, what is a very radical measure in electrical power system. So when it comes to active control, corrective measures, then I would be still careful when it comes to applications based on artificial intelligence-based approaches. But I, however, see lots of space for research, helping and supporting power system wide area control, for example, measures what has to do, for example, with frequency control, what has to do with protection measures like under frequency load shedding, when we have to intentionally disconnect the load to ensure active power balance in an electrical power system, making sure that the system will be operating in a stable manner.